Hello everyone. Today we are going to work on the Altium Designer software. This is going to be a very short and quick tutorial. I'm not going to go in a lot of details of manipulating so many things in Altium Designer. That will be a very to the point, quick tutorial for so many people who would like to learn. The most basic thing that I'm going to explain here is the workflow that we'll have to follow, and this workflow will never fail you if you just keep that thing handy all the time. And if you just remember that part, you will see that designing a circuit right from the time where we do the part search and we make a schematic to the point where we make the PCB and then generate the manufacturer files, it will be a very easy process. So we'll start with this is the general Altium Designer's interface. I'll just quickly go to this presentation which I've made. So first of all, we'll follow the step-by-step stuff. We have to create a project and then add the following files. So I'll create a project first of all. So that's my Altium. To add the project, I'll go to File, New Project. Perfect. I can browse and give it and tell the system where to save my project. I've chosen this Altium project. I'm going to call it YouTube LED. That's the project. I'm going to take a most simplest circuit which I'm going to show you guys. So I said that create my project. It's creating project. It'll take a couple of more seconds, I would say, and would create a project. All right, the project is created, YouTube LED. So I'll go to the PowerPoint slide. What is the next thing? Add the following files. What we have to add? We have to add a schematic document. Perfect. Add a schematic document. Right click the project. Add new to project schematic. That's what I mean from a schematic document. I've added the schematic document, and it has been named by default sheet 1 dot schematic document. Perfect. I'll go again to my presentation. What we have to add next? A PCB document. All right, we'll go to the project, add new to the project PCB document, and a new PCB document is added. This is the place where the PCB is. We have the board layers here. I go back to the presentation. I have to add a schematic library. Perfect. I'll go to the project, right click, add new to the project, schematic library. Okay, so one thing, when I add the schematic library, the system actually switched just like it did for the schematic, and it did for the PCB document. When I created the PCB document, the tab actually switched to the PCB document, right? And then it switched to the schematic document. Right now, it has switched itself to the schematic library. And in library, by default, there's a component _1, which is actually nothing. It's a 0 component. And if you click it, you don't see any schematic symbol for it. So it's just there. So once we have created the schematic library, I'll go to the projects. You see these small tabs here. I'm going to go to the projects tab so that I come back to that project pane. I'll go back to my slideshow. Now I have to add the PCB library. Perfect. I'll go right click and I'll add new to the project, a PCB library, and it will switch to the PCB library. It did for each and every other document. And I have to switch back to my projects. I'll click here to the projects. So we have added 4 files. File number 1, file number 2, file number 3, file number 4, and everything is defined here. I've added a project, created a project, added schematic document, PCB document, schematic library, PCB library, and we have created all these files. Once they are all done, I don't want to name them. I'll keep the default names, but it's easy. You can always right click and rename or save and rename. I'm going to say Control S and save my project. Not the schematic library. I'll right click here to the project and I'll say save my project, not the PCB document. Okay, so I'll say okay if it wants me to save, because that's the prerequisite to save this project. There's a prerequisite to save the other files. I'm going to save again. It wants to ask me if I would like to save it. Yes, save the schematic library and save the schematic document, and done. It's done. Finally, that red thing is gone. It means the project is saved with all the default names. Perfect. Now, why we need a schematic document? First of all, schematic document is the place where we make the actual circuits. In our case, this is our circuit, which is we are going to make. It's the most simplest circuit. We have a resistor, we have an LED connected to it, we have a positive power supply, we have a ground, and both of them are connected to a header pin. It's a two position header pin, where we'll supply the 5 volt from a battery and a ground from a battery. So that's the circuit we would like to make. And that circuit should be present in our schematic document. But we don't have the schematic document yet. We have the schematic document. We don't have the components yet. So we need to put these components in the schematic document. I need a resistor, I need an LED, and I need a header pin. And where would I get these symbols from? For that, I'll have to go to the schematic library and create my symbols here, create or download my symbols, which then I can use in my schematic document. Okay, that's the theme. So what I mean here is that to make a schematic, I need the components. So actual circuit diagram, which I'll make from at the schematic document, using symbols which are schematic symbols from schematic library. So in schematic library, I have to download or create my circuit component symbols. Once that is done, we'll follow the next steps later. We'll talk about the PCBs later, or perhaps just it's the same theme. When we go back, when we have created our schematic document, then we would like to create our PCB document and import all our component symbols into our real PCB physical environment. For that case, we would like to create a PCB with all the footprints. So that's the nomination, the real physical pad with the component length. In our case, I'm going to use 0805, which is 8 mils by 5 mils length and width. We're going to create the PCB footprints, means the actual PCB pads that will be created by the manufacturer. But to get those PCB real pad components, we'll have to get those footprints, and those footprints will be available in PCB library. So we'll have to create a PCB library too. So that's the whole thing. Let's go back to our schematic document. Now, since we have to make this circuit, let's look for the components. So first of all, I've made a list of components that I use for my labs. So this is the component manufacturer part number. I'll go to my schematic document. The way to search, there are 2 different ways, actually 3 different ways to make the schematic symbol, and I'm going to teach you at least 2 quickly. So I'll go to the panels. In the panels, I'll go to the manufacturer part search. In the manufacturer part search, I will search for this component which I've copied, and I'll look for the suggestions. I'll select the first component, and when you see the component have this green icon that you see here, a green IC, that means that the Altium itself has all the footprints, the schematic symbol. As you see here, it has a schematic symbol as well as the 2D footprint, and for the 2D footprint for the PCB, as well as the 3D model for that system. So that green symbol shows that if I use that component, then I don't have to do the extra work of downloading a component and then making a library and then importing the items from the library. So first of all, I'll do the easiest way. In the easiest way, when you see this green icon, it means that you can directly place this component in schematic document. I'll right click, and then I don't have to go into the details. These are the supplier names, what suppliers have these components, and then there's a list of all the suppliers and their current real-time stocks. So we are not interested in that. So I'll just right click and I'll hit the place. Place means come here, place a component. Place, where are you? Okay, here's the component. Here's my first resistor component, and to rotate it, I'll have to click the space bar. So once I click the space bar, I'll take the number 1 pointer here. So I've clicked the space bar, and now I have the resistor. I'm going to place the resistor, and then I'll hit the escape key so that I can go back to the to our component part search. All right, now the next thing we would like is an LED. For an LED, I need the SMD LED 0805 size, so that's what I'm going to do. I'm going to search for SMD LED, and we can gonna use the filters from the left pane so that you know how to use the filter. So all these green symbols shows that we have the availability of the schematic symbol, the 2D and 3D footprints of this LED. So here, these are the case and package sizes. This is what I'm looking for. 0805 is going to filter, and we're gonna find the first. So the first LED is how does it look like? Okay, which is okay. I mean, okay, I'll just pick up the. If it doesn't look good, I'll just pick up the one. It's taking time to download. All right, I'll just pick up the first one, and again, now I'm going to show you the next way of when there is no. When there's green symbol, you can always do that. You can just right click and place them. But when it is not, when there is nothing like that, you would like to download it from the internet. You can go to Octopart, you can go to EDA website, you can go to different places to find their symbols. But ultimately what you'll have to do the downloading. I'm going to download here. You can tell the system, the library, the place where you would like to download its components. Okay, I've downloaded it here. Okay, again, what was the directory? Let me go click the download. It's still downloading. Okay, component successfully downloaded. I'll hit the download key. I'm going to copy this so that I can explore it directly. So explore and go directly to this library. Here's the component. I'm going to right click 7-zip, extract to this. You should always name them like component LED, for example. Okay, now within this components, I have the schematic library and the PCB library. So I would like to have the schematic component as well as the PCB library component of this system. Now you see these are not the schematic document, these are the libraries. So what I would like to do, I would like to close this thing, go back this. I'll take this schematic library and just put it there directly, just drop and drag. So once I dragged it here, you see that again the similar thing continued because it was a library. It opened that library. Here's the tab of the library, and this is the name of the component within that library. This is the schematic symbol. Right now there is no footprint attached to it. You see there's no footprint. If there was a footprint, we will be able to see its preview here. So what I would like to do, I'll right click this component from the library because we have downloaded and we have imported the library. Do you see that .schematic library here in this tab? I'm going to copy the component from this library. I'll go back to my projects. I'll go to my own library, which is here. And remember, there was only one garbage component in it, which has no value. It was just one default file name called component_1. So I've clicked that schematic library, and then I will go here and click that schematic library tab. Okay, that's my use this component. It has nothing. I'm going to right click and paste the LED component that I've copied. Now actually I can easily delete that. Doesn't mean, but before that we cannot delete because by default it should be there. I can delete, yes, delete it. I don't want this component, and now I have my LED symbol here. Perfect. I'll go back to my projects, and remember that the documents that we import, that we click drag and drop, they are opened in something we call as free documents, source documents. All the things that you import, they just go into the free documents. It means free documents are not exactly the part of the project, but these are some spaces assigned to them for any components that we would like to import. Okay, we have the schematic symbol. We don't have the footprint yet. Footprint here means a PCB footprint. So this terminology is important. Whenever we say footprint, it means PCB footprint. How this is going to look like on a physical PCB printed circuit board. That's what the footprint means. So we don't have the footprint yet. All right, we'll go back to our folder again here, and now we're going to import the PCB library. All right, so what happens? What do you think will happen when I'll drag and drop? It is going to switch to the PCB library. All right, remember that. So we'll go back to the project. So I've copied it, and here it comes. So it has now switched again to that library. So I'm going to copy this component. I'm going to go back to the projects. I'm going to go to my PCB library and then hit the PCB library from here. There was a PCB component that's again similarly a default component, has no value, no pads, no primitives. I'm going to right click and paste one component here. That's my PCB component. Perfect. Now I can delete that component which was here by default. All right, now I have the PCB footprint here. All right, now I'm going to go back to my projects and I'm going to hit save all. For example, there was a save all. Where is save? Okay, I'll just hit the save. And when I say hit save, it's going to save all the relevant files. Save. Perfect. Now intelligently, what happens when we've copied the same similar name files in the schematic library and in the PCB library, then the schematic library automatically attaches that footprint. That's the beauty of it. It would happen normally. Otherwise, we'll just direct the system to where to look for the footprint. All right. So you see, I mean, the footprint has been, so the system all automatically attached the footprint now, and we can see the footprint here. You see 2D and 3D footprints are now available. Their preview is here. So we are good to go. So we don't have to manually. Otherwise, if we have to do it manually, this is how we do. We just, for example, hit the add footprint, and then we browse the place, and the browse we go back to the library from where the footprint is present, and then bring it here. So it's an easy process. I don't want to go into the details, but you now know how to download the components and how to extract them and copy the libraries. It will be switched. You see components, libraries, both of them will be switched, and they will be into the free documents. We just copy the components and put them in our own libraries. All right, so these two components are now available in our library. So we can go back to our sheet, the schematic sheet, and now I would like to place these components from my libraries. Now you understand the whole workflow. We had a schematic document, and in schematic document we want to make a schematic, but we don't have a component. So we go to the schematic library and bring in the circuit symbol. We go to the PCB library and bring in the PCB footprint. So let's go back. How would we place the components? You just have to go to the panels. In the panels, click the components. When you click the components, here the components are open. Now it is asking, where would you like to get the component from? From the PCB library? No, we are making a schematic. We need a schematic library. Where's our schematic library? Here it is. Oh, perfect. We get our schematic library. Here's our schematic library symbol. You right click and then place and then bring this LED. All right. Here is our LED. We place our LED, right click, perfect. All right. Then we can just click. We can just dock them, or we can close them. That's okay. Both are same. So I'll just dock it. Oh, sorry, I closed it. Sorry. Okay. So we have these two components, and now I would like to bring in the from the manufacturer. I'll bring in the header pins. I have to go quick, otherwise this video will be too long. In the component, sorry, not the components, to the manufacturer part search. Okay, where is my Excel sheet? What is the name of the header? 2 position header pins. So I have searched the components with, with the which already have their green icon with them, so we can look at the foot models, not the 0805. That's why I didn't search. All right, these are the header pins, because it has that green thingy, so I know their footprints are available, and actually you can see them here. This is the schematic symbol, this is the footprint, and this is 3D print. This is how it looks like. Okay, so I'm going to do the same thing. Right click, place, please. Here it is. Okay, I'll right click, And actually the pin 1 is on the top, pin 2 is there, so I'll click the X, right click, X means to mirror, and then I'm just gonna place this thing here. All right, right click. Perfect. Now I don't need my manufacturer part search anymore because I took all the components. We still have to connect the power and ground. For the wire, either you click this line or you just hit Control plus W. When you hit Control plus W, you have the wire, and then the wire, and then again wire. Sorry. Okay, wire. And then just to add plus and the plus VCC and the ground, right click. All right, now once this is done, let me oh, this is not connected. Control W. All right, this is now connected. Okay, now once this is done, I would like to click this wire and hit the properties. Sorry, I'll just go to the properties panel. Even if I don't hit, here is the properties panel. Now I would like to bring this ground. All right, I'm going to bring this ground and I'm going to attach that ground here, and I would hit the tab key so that I can look at its properties. When you hit the tab key, you see the schematic the work stops. It just pauses. Now I'll go, I want to name it as a ground. Yes, it's a power ground. Yes, perfect. Okay, perfect, we've placed it. So I need the ground. Now I will just hit the pause key and I'll hit one more ground, but now I don't need ground, so I'm going to pause it again, hit the tab key. I'll say no, name it 5.1 volt. This is how we write the 5.1 volt, and its rotation should be 90 degrees. Okay, and its style should be arrow. Okay, that's what I want. I'll go to pause. I'll come on here and hit the 5 volt pin here. So that's what my circuit looks like. Plus VCC is equal to 5.1. Okay, I still have to name it as a VCC. Yeah, let me just name it. Okay, wait, tab, no properties, then I'll open the properties from here. Properties name is VCC is equal to, all right. So that's how I've named my VCC is equal to 5.1 volt. This is my ground. This is my picture. This doesn't look connected. Wait, there is this. Yeah, it wasn't connected. So Control Z. I'll just bring that component. Okay, now it looks connected. Okay. All right, I'll just Control save my schematic. So my schematic is now done. It has all the components. The next thing I would like to get rid of these question marks, and I don't want to see these names. So if I don't want to see these long names which are manufacturer part names, I'll click the properties. I'll just say, I'll hit that eye icon, so don't show me this. For the diodes, don't show me this name. For my connector, don't show me this name. Okay, but I still want to change my designators, because right now if I have more resistors, how would you like to name them? You should be naming it as R1, R2, which we can do by clicking, and then we can just hit the properties and we can name it like this is the designator R1, R2, R3. We can do it, all of these things, but there's another way. We can go to the tools and we can go to the annotation. In the annotation, we'll go to annotate schematics. In the schematic, I'm asking the system to name my resistors in such a fashion. If I had more than one resistor, just name them in this fashion or this fashion or whatever we like. I can have my one of the sessions. So I'm accepting whatever is default. It's telling me that proposed change list is this. G, D, and J connector and R, they will be named into something new. I'll say okay, update changes list. There will be 3 changes made. Okay, perfect, no problem. Now update changes list, and then accept changes. Accept changes. They are changing D to D1, J to J1, and R to R question mark to R1. Yes. Execute changes. All done. Close. Close. And my files, my resistors and diode and J1 connectors are already named, designated. Perfect. This looks good. I'll have to go. I'll just save this. Control S. I'll save this one, and I have to quickly import it to my PCB project. Okay, so for that you will go to the design and update PCB document. You click that PCB document. It is telling us that these are the things that will be taken to the PCB document. Okay, execute changes. Done, done, done. Okay, here's my PCB. Close. We can close it. This is showing me the actual PCB dimension. This is a two-side PCB board, and it is so big. But this is my connector. This is my circuit, which is too small. Okay. First of all, I'm going to delete this housing because I don't need it, and then I will just hit the control key, make it small, take them all, and put them somewhere here. Perfect. Now I need a very small PCB for that. So to get the small PCB, first of all, I'll go to the view. In the view, I'll go to the board planning mode, or you can hit the one click key. I'll go to the board planning mode. I'll go to the tools and to the design and redefine, edit board shape. In the edit board shape, I'm going to do this. I'm going to do this. I'll still keep my board a little bit bigger so that I can put in some text, of my choice. Yeah, I think that's a good board. And once this is done, I would like to mark this point as 0, 0. Right now, if you see, if I bring my mouse here, this is not 0, 0. X and Y has some number, you see. So let me put this as a default 0, 0 so that I can actually look at the placement of the components, that how far I can place them. So I'll go to edit, I'll go to origin and set origin, where? Control and the mouse wheel. I want to set my origin here. So you see right now when I put my mouse here, it is telling me X and Y is 0, 0, all right? Exactly in the middle, X and Y 0 mil towards this corner. So okay, now view and then fit my board. Perfect, that's my board. A little too big still, but it's okay. Okay, right now we can go to the view and 2D layout mode, and this is the mode where I would like to route my PCB. If you see, these wires tells us, these fly wire lines, they tells us how our PCB points are connected. So remember, I'll just follow the same theme. There was a resistor. So remember, in PCB, when you would like to rotate the component, you will still do it by the spacebar, but all that time you should be holding on your component. If you leave your component and then hit the spacebar key, nothing's going to happen. So you hold your component and then hit the spacebar key. Okay, this is very important. So many newbies make this mistake. They try to do it and it's not possible. All right, so this is the ground and this is plus VCC. I'm going to rotate this. Okay, plus VCC, ground. Actually, we can do one more thing quickly. If we go to sheet 1 document, these things have the net name. So this is having the VCC 5 volt as a net name. This one is a ground. Let me just put a net label here. Always go to the place. Whenever you want to place something, place net label here. And what is the net label that you placed? Go to the click to the properties, and I would like to say LED. That's it. That's my net label. Perfect. I would like to save this. Okay, and then I'll go to I'll go to validate PCB. Update PCB document. So it will be updated based on the new things. Okay, yeah, execute changes. Perfect. Close. So you see, that is important. Now this is VCC. I hope there is no, yeah. So let me just delete that home which was created. So that thing was making this system all green. So it means that another home was created. All right. So, and then I'll click my LED, how my LED is connected. Is it okay? Is it like this? No. sorry, in my schematic document, my point 2 is connected to the ground and LED side, and the other one is connected to R. So here's my R, here's my R, and here's my LED. So I'll rotate my LED here. This is the way. Why this wire is here? I think there's something wrong, because this wire shows me that this is LED wire is connected directly, so something is not connected properly. What is that? What is that? Let me delete. Let me Control W. Connect. 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 Okay, let me save, and let me go and again go to the design and update my PCB document. Okay, execute changes, close. You see that green, it means there is a housing imported here. So just delete that, and the green thingy will go away, and then now it's better. Now it's actually correct. All right. You see now ground line is connected to the ground line of LED, and LED is connected to, this is according to the net name, and this is connected to the resistor. So I'll just follow the same thing. A little bit resistors up, diode up. This is my connector. So that's my PCB. Again, I'll use it for interactive routing. I'll just use the Control plus W. I will just quickly explain vias, how you can pause and go to the back of the board. It's not important here. I can always do another tutorial on that, but right now let's quickly see. I'll hit the Control plus W, and you see I have this connector. So I'll go to the middle of this. When I go to the middle of this, you see that the cross wheel changes. So right now it's plus, and when I go to the middle, it becomes that cross. It means it is now connected. I'll take this. I've just clicked it, and that's the interactive wiring. So it is going there. I'm going to connect it to this. Once it is in the middle, you see it again changes to the red color. Perfect. Then again from here to LED, I can just directly connect these 2 points, but or I'll still do it. It's okay. For the ground, I'll go back to the backboard. So for the ground, I'll go here, and I'll go here. And right now, I just don't want to directly wire it. I want to go take that wire from the other side of the board. So what I'm going to do, at this point, I'll click, and I'll hit the tab key. Tab key means paused. I'll hit the bottom layer. So I'm now at the bottom layer, and the system automatically places a via. A via is a hole which takes you to that other board. And you see, if I start wiring now by saying no more pause, the next wiring will be blue color, which shows that the copper connection is towards the other side of the board. So I'll say not hit the pause, place the via here. All right, and now there's a blue wire, and you see that circle. Perfect. And that's your wire. So that once this circuit is done, let me quickly put, because when you make a board, you would like to put your logo, your name, whatever in there. For that, we always use a top overlay. Okay, so top overlay is something that we use. That yellow thingy, that D1, that's what that top overlay is. And where is top overlay? Here. So you click the top overlay, and then you bring in some text. Here's the text. Okay, string. Sorry, go to the properties, and instead of string, I'll say YouTube tutorial. All right, that's it. And you will see, go to view, go to fit board. This is YouTube tutorial. I'm going to take it. I'm going to put it here. All right. So once this is done, there are more things, like there are design rules, what should be the size of the via and everything. We have to quickly look at that point, but right now I would say at this point hit the 3 key or go to the view and see the 3D layout mode, and you'll be able to see your 3D project. So you see that's your resistor, that's your diode, this is your these are your header pins, and you see that via as a whole. which just took that connection, took it to the ground, to the next board type side of the board, and it connected as a wire. All right, this happens when there are a lot of wires that we would like to not to cross, then we use the VS. All right, that's how we create it. We go back to the create the PCB, go back by clicking the 2, we'll go back to that 3D project. And what else I can tell you here quickly, the top overlay, the front and back. All right, at this point, let me quickly look at let me save the document, go to the design, and in the tools, design rule check. We can set some rules, but right now I just want to quickly check with default rules if it works. If it doesn't, we'll quickly fix those errors. Messages. Okay, there are no rule violations, so everything is okay. Right now everything is okay, so perfect. But if there are violations, we can always go to the PCB, and in the panels look at the PCB rules and violations, and then it shows us the list of the violations. We can click them and we can reach those violations. Right now there are no violations, so our system is ready for the manufacturer part generation, for which I'll just save. What I would like to do, I would like to add the last one final, add new to project, where are the output job file. So I've created an output job file, and it is going to switch to the output job file, right? I mean, like it has been doing all the time. Okay, here's my output job file. Here I'm going to go to the fabrication outputs, add new fabrication file. So just click that, add fabrication. First thing I would like to go is with the Gerber files for the PCB document, and then configure, and right click and configure. In configure, inches, millimeter, doesn't matter. Layers, in the layers, this is important. I will say plot layers. What layers? Used on. So right now nothing is selected. When you say used on, then all the used layers will be selected. For the other things, we don't need anything, so we'll just say hit the OK key. Perfect. Now I'll go to add new file. I'll go to the drill files. Drill files are important because they have to make the VS, they have to make other holes for the PCB. Drill files, I'll right click and I'll hit the configure. In the configure, inches, millimeter, everything is good as by default. I never change them. Here I'm going to click this. I'm going to click the folder structure here. Okay. In the folder structure, I'm going to connect this folder structure to both of them, and the generate content. I'll say generate content is going to generate the Gerber files, which goes to the manufacturer, as well as the NC drill files. These are the two files, and we can actually right now I would like to save. Okay, I would like to save my project. Okay, so right now these two files are generated, and they are generated in the project where we put our where are documents? In the documents here, in the documents, Altium projects, YouTube LED. All right, here are the job outputs. So we'll go to the PCB logs output for free documents. These are the Gerber and NC drill in one folder. You go to the Gerber, you submit all these files to your manufacturer for the Gerber files, which have your PCB information, and this text file for the drill. This only text file is enough, which guides the lathe machine or the PCB machine that where it has to make a hole on a PCB. That's it. And once this is done, your PCB is done. We can now make more complex PCB projects. Okay, let me quickly go to the once this is done, we are done. Schematic document, we made a schematic document, we named the nets, and then those nets were helpful. We made a via, and we checked that how did we change the via. And I was talking quickly about the design rules. We can go to design rule check, and this is the place we can go to the tools. Where are the design rules? Quickly. Okay, I'm sorry. View project. Where are the design rules? All there somewhere. I mean, right now that's not important. Design here, rules in design. They were there. So in the rules, this is the place where you normally look at the rules. In the routing, we always look at the width. In the width, we define that what could be the minimum width track, and there are online places where you can find that according to your current, what will be the pad length for your wires. So you can define that what would be the minimum, what would be the maximum, and the preferred width. Normally preferred width will be used. We use the width, that's important. And then the other important thing here is normally the clearance. Clearance means the component to component clearance. So like this pad and this pad, what would be the clearance between them? We can always choose the minimum clearance and guide the system. And then there are the vias, routing via style, routing vias. And then this is the vias, how much is the minimum and maximum diameter do you want? Because normally when we want to put a PCB board and we want to make, you know, the 4 holes to put the screws in it so that we can fix it. So I choose a via of a very large diameter, so of my screw size, so that when our board comes back, it has those holes and I can fix that PCB. I hope this video was very quick and it was able to help you guys with so many things. See you. Bye.